Good morning. How you guys all doing today? So this is a lesson that I wish I could do with you in school. It's so much fun and there's a really lot of neat little things. So if you want to do this with me on a piece of grid paper, feel free. Um, we're going to look today at the connection between similar figures with their perimeters and their areas. And you're going to see there's a really neat connection. So first going to start with this shape right over here. It's just a 3x2 rectangle. So the perimeter of that is pretty simple. It's just simply 10, right? 3 plus 3 is 6, 2 plus 2 is 4, 4 plus 3 is 10. I am not going to put units down. Just know that for right now. I'm more worried about the numbers right now. So the area of that is going to be 6. So let's say we were to double the length and the width. Okay, so what does that look like? So if I double the length, right now it's 3, so it needs to become 6. So that's a double of the length. Now I need to double the width. So if the width is 2, it needs to become 4. So now I have a 6 by 4. Well, what is the perimeter of this? Well, 6 and 6 is 12. 4 and 4 is 20. What's my area now? Well, my area is 24. Okay. So let's try another one, right? This time, instead of multiplying length and width by 2, let's do length and width by 3. So there's 1, 2, 3. So I tripled the length, right? So it's 3. Now it's 3 plus 3 plus 3 or 9. Now I need to triple the width, right? Because remember, we have to do it to both directions. Otherwise, it's not going to be similar. So let's put that in. So now I tripled the width. It was 2. Now it's 6. So I have to fill everything in. Oops, I clicked the wrong button. Let's do that. There we go. Okay. So now what would the perimeter be? Let me just put in here the 6. The 10 and the 6, just so we can do some comparison in a few minutes. All right, let's do the area. The perimeter of this one is 9 plus 9 is 18. And then this is 6 and 6 is 12. 18 and 12 is 30. The area is a 9 by 6, which in this case is 54. So now, the neat thing that we would do next is we would actually do some comparisons. I'm going to do it here, but it's kind of cool if you guys were to do it. And you're going to notice that there's something that's connected. So the perimeter, what we're going to do is we're going to find, we're going to try to see if there's a ratio between the perimeter and the two areas. So this is pretty easy to see. Okay. So we doubled it, or we had a scale factor of 2. And if you notice, the ratios of the perimeters is 2. Here we had the ratio of, again, we had a ratio of 2, right? We had a scale factor of 2. So what's the ratio of the area? So the perimeter of this one is double of that one. Well, what's the area going to be? Okay, so that's going to be 24 divided by 6, which is 4. 2, 4. Is there a connection? Of course there is. Let's come over here, do the perimeter of, we multiplied it by 3 times. So 30 divided by 10 happens to be 3. Okay. Now let's do the area. Oops, helps if I put an equal sign in. 54 divided by 6 equals 9. So is there a connection between 3 and 9? As well as connection between 2 and 4. Hopefully you're seeing that. 4 is 2 times 2. 9 is 3 times 3. So there is a connection between how the perimeters of similar figures are related to one another and how the areas of similar figures are related to one another. So let's see what that happens to be. Okay, so basically, if you have two similar figures, the perimeter of the figures is going to be basically the scale factor. So that's what this is talking about. So the perimeter of the smaller triangle and the perimeter of the larger triangle is going to be equal to the fraction of, or the ratio of, corresponding sides. Okay? And we talked about that last time. That's just the scale factor. So the perimeter increases by the scale factor. So if we were to come up here, what would the ratio of this perimeter be to this perimeter? Again, it's just a scale factor. So in this case, it says go from red to blue, which means red's on top, blue's on the bottom. So that would be the perimeter of the red rectangle to the blue rectangle is going to be a ratio of 4 to 6, or 2/3. It's pretty simple. What would the area be? Well, we noticed we said 2 and 4 is 2 squared, 9 was 3 squared. So the area goes up by a square. And it kind of makes sense because if you notice this, we're doubling the length and we're doubling the width. So this is going up by a factor of 2. That's going up by a factor of 2. And 2 times 2, which is 2 squared, just happens to be 4. Here we did the same thing. Here we tripled the length and tripled the width. So that's 3 times more that way, and 3 times more that way, and 3 times 3 is 9. So when you're changing the area of similar figures, or how they're related, is the area of one is the scale factor squared of the other. So obviously going this way, the number would be bigger than 1. Going this way, it would be small, between 0 and 1. Okay, it will work every time. So the areas of the two, you just find if you have corresponding sides. Okay, you take those sides, make it as a ratio, and then square it. So let's do it with this one. All right, so we know that these two are similar because they tell us. We want to find the ratio of the areas of the red one to the blue one. Well, what we need to do is write the scale factor, which in this case would be 6 divided by 10, or 6 to 10. To make your life easy, just simplify that first. So it's 3/5. Because we're finding the area, we square it. So that would be 9/25. So the area of this would be 9/25 of this one. Now, if you remember, we talked about scale factor is there's always 2. So this one would be 25/9 of that one. Okay, because one way, you use the reciprocal to go the other direction. So let's do a little situation. So we have a pool and we have a volleyball court. They are similar because they tell us that. We need to find the perimeter and the area of the pool. Well, we don't. We know one side of the pool. We know the area and the perimeter of the actual volleyball court. So we're going to use that to help us out. No, we do not have to find the length of the volleyball court because the perimeter of the volleyball court divided by the perimeter of the pool has to be equal to the ratio of corresponding sides. Okay, because the perimeter changes the way by the scale factor. So we just plug our numbers in. Okay, so the perimeter of the court is 60. We don't know the perimeter of the pool, but we do know that the corresponding side of the court is 10 over the corresponding side of the pool, which is 18. Now, what do we get? Multiply 10 by to get to 60? Well, we multiply that by 6. So 18 times 6 is going to give us 108. I know I didn't label it yet. We'll get to that later. Now let's do the area. So same thing. The area of the court divided by the area of the pool, or the ratio of the area of the court to the area of the pool, is going to be the ratio of corresponding sides squared. We just plug our numbers in. The area of the volleyball court is 200. We don't know the area of the pool, but we do know that the corresponding sides has a ratio of 10 to 18. And we can square that. Now, I didn't simplify it first, only because 100 to 200 is pretty easy. You're just doubling it. Okay, 324, we double that, comes out to be 648. So the perimeter of the pool is 108 yards. The area is 648 square yards. So let's just review real quick. How are the area and perimeter related in similar figures? Well, the perimeter goes up by the scale factor, which was just the ratio of corresponding sides to one another. The area goes up by the scale factor squared, or the ratio of the two of corresponding sides squared. Good luck. Reach out if you have any trouble. Have a good day. Bye.